Looking at this series, I'm debating whether I want to try a ratio test or a root test. And keep in mind, as I mentioned before, there isn't just one right way. Sometimes there's more than one test that applies, and you can choose which one you'd want to use if you meet the conditions for more than one test. And of course, you should always get the same conclusion whatever test you used if it's a valid test. I think I'm going to do the ratio test. So the ratio test says if we take the limit as n goes to infinity of the absolute value of the n plus 1 term, so I'm putting n plus 1 in anywhere I see the n, divided by the nth term, so that's n to the third over 2 to the n, then I need to compute that limit, and if that limit is less than 1, then I have convergence. If it's greater than 1, I have divergence, and if it equals 1, I don't know anything, and I'm going to have to try some other test. So now I can flip this over, so I'll have 2 to the n on the top here, and n to the third multiplied here on the bottom. Now we can go ahead and express these just a little bit differently here. Looking at the top, n plus 1 to the third, I think I'm going to go ahead and write that out. That's n to the third plus 3n squared plus 3n plus 1. And I know that kind of because I recognize it's a binomial, but you could also write this out 3 times and multiply it together to find this. And then we have 2 to the n. And on the bottom we have 2 to the n, 2 to the 1, just using rules of exponents, and then n to the third. Now I wrote it like this so we could see that these would cancel, and then as I'm looking at this I could multiply numerator and denominator by 1 over n to the third, and so what I will have is the limit as n goes to infinity of 1 plus 3 over n plus 3 over n squared plus 1 over n cubed, and that's over 2 because our n to the thirds cancel there. So now as we let n go to infinity, we see all of these terms are going to go to 0, and so we get 1/2, which is less than 1, and therefore by the ratio test we have convergence.